Hello students, welcome back to my channel. I'm teacher Dadian Baluka, your chemistry mentor. Remember to subscribe and click on the notification bell so that you can be notified once I upload a new video. In our today's video, I'll be dealing with extraction of metals, and our topic of interest will be extraction of sodium metal. So we are looking at this particular metal. Of course, I'm uploading all of them, but we'll start by looking at the checklist. So what am I going to handle there? I'm going to handle specific areas that are mostly tested in the exam. So by the end of this particular video, you should be able to name at least 2 moles of sodium. You should be able to name at least 2 moles of sodium. You should be able to describe a test for presence of sodium ions. You should be able to talk about look at the electrolytic extraction of sodium through the downcell. In that particular diagram, you should be able to label the diagram properly. Where is the cathode, where is the anode, where is the region containing the electrolyte. Then you should also be able to, of course, explain the role of the diaphragm and also the hood and the iron wall, which is lined with fire bricks. You should also be able to state, or rather to explain, why calcium chloride is added to the molten sodium chloride, or rather why it is added to sodium chloride, or rather why it is mixed with sodium chloride. Why sodium and not calcium is selectively, or rather preferentially discharged at the cathode. You should also be able to name the uses of sodium. You should also be able to explain the environmental effects which is caused by the extraction of sodium metal. Name an industry that should be located near the sodium extraction plants. And of course, something that is not captured here, you also need to be able to explain why maybe after some time, we're also going to have the calcium being discharged at the cathode. How can you be able, what properties of calcium that makes it possible to be separated from molten sodium? So watch until the end. Work with me as I try to navigate this interesting topic. Remember this topic, this is an area that is usually tested in paper 2. And the question in paper 2 has a weight of between 10 to 12 marks. 10 to 14 marks. So it's very much important to be able to understand that. So we start by looking at the first objective, which is being able to name at least 2 moles of sodium. So the first O is the rock salt, which is the chief O. And the formula of the main component of the rock salt is sodium chloride. We have the salpeter, whereby the main component of salpeter is sodium nitrate. We also have trona, whereby the main component of trona is as shown in that particular formula that is shown on the screen. So after being able to name at least 2 moles of sodium, we go to how do you confirm, how do you test the presence of sodium ions in the O? The first step, wherever you are given a metal, you must convert it into a solution which contains the metal cations. So this one, because all sodium ions are soluble, you'll start by add water. You can add water to a portion of the O because all sodium salts are soluble. Then you stir. Filter to remove undissolved impurities. Then you carry out flame test. And in a flame test, you dip a glass rod, or rather nichrome wire, into the filtrate and burn it at the top of a non-luminous flame. So the yellow flame confirms presence of sodium ions. Very important. Let's look at we have named the old, we have confirmed presence of the old. Now we go to the next part, which is also tested mostly in the exam, the extraction of sodium. It is extracted through the downcell. The sodium is destroyed by electrolysis of the fused calcium chloride. So in short, we are saying the sodium is extracted through electrolysis of fused, or rather molten sodium chloride. The most used, or rather the commonly, or rather the ore that is mostly used is the rock salt, because it is the most abundant and also requires very little purification. Therefore, that is why we preferably use the rock salt and not the salpeter and the trona. Now we have looked at that. We need to look at something else. So during the extraction of sodium, the sodium chloride is fed to the down cell, and it iterates strongly to melt it. We melt it so that now we can now convert it to the mobile ion that also becomes a good conductor, because we're using electrolysis, whereby you use electrolysis. So the solid, the sodium chloride, cannot conduct electricity. So once it has been purified, it is fed to the down cell. And then it is heated to melt it so that it can allow electrical conductivity. It is mixed with calcium chloride. Why do we mix it with calcium chloride? In order to lower the melting point of sodium chloride from 801 to 600. In many times, the examiner will ask you the role of the calcium chloride. The marking point, you don't need to measure the exact temperature, but measure that you are able to measure that. The calcium chloride, the role is to lower the melting point of sodium chloride. Don't just say it is to lower the melting point. That is a very general statement. It is not scientific. Remember, scientists are very precise. So you have to tell us the role of the calcium chloride is to lower the melting point of sodium chloride, not just lower the melting point, because that does not make a lot of sense. So, but if you may mention the temperature, the temperature range, but it's not important. It's not a must, because if now you have to measure it, it has to be specific. But the most important that point, as I shown there, say it is lower the melting point of sodium chloride. This also helps to lower the fuel cost, because somebody will tell you, there's also another, in many times an examiner can ask you can be asked that a question can ask why the electrolysis is not carried out at 800, because a lot of fuel will be used to maintain such a high temperature. Therefore, we lower the melting point in order to lower the fuel cost. Now we are looking at the extraction of sodium through the down cell now. The entire chemistry of extraction of sodium is there. Listen and listen very carefully. We put the fresh salt into the downside. You are able to see the fresh salt in there. Once it is there, it is mixed with calcium chloride, whose role is to lower the melting point of sodium chloride from around 800 to 600 degrees Celsius. Then from there, you can see we have the steel wire diaphragm there. This is whereby we are having the cathode. This is the cathode. You can see the cathode is there, the cathode is there. So this being the cathode, we have now the electric current which is passed through here. So once the electric current is passed through here, it's going to decompose the sodium chloride into sodium and chloride ions. The calcium chloride will also be decomposed to calcium ions and chloride ions. So in that kind of scenario, we have the steel wire diaphragm. You can be able to see it here. Then we are saying at the cathode here, we are going to discharge sodium. So here we are going to have the sodium being discharged here in this particular point. So I think I can be able to write something there. So we have the sodium. We have the sodium being formed here. We have the sodium. And here we have the chlorine. Here it is the chlorine gas. Chlorine gas will be formed here in the anode. So here we are going to have the sodium ions. Sodium chloride decompose to form sodium ions and chloride ions. The sodium ions will go to the cathode, get discharged to form the sodium ions. So you're able to see here, the sodium ions will go to the cathode here and will be discharged to form the sodium ions. So you'll gain electron to form sodium liquid. So the chloride ions, which are negative, will always move to the anode, whereby it's going to lose electron to form chlorine gas. The chlorine gas will now be able to be collected and directed out via the hood. So in that kind of a scenario, this one is tapped and is not released to the atmosphere because chlorine is highly poisonous. Remember, there was an area of the environmental effect. So we can have the chlorine gas being discharged, which now, once released to the atmosphere, is going to bring about the pollution effect because it's very poisonous. So between the cathode here, you are seeing we have the diaphragm. What is the role of this diaphragm? The role of the diaphragm will prevent the products of electrolysis, that is chlorine and sodium, from coming into contact, of which they are going to violently react. So you can be able to see from here, we have the anode here. We have the anode, chlorine being from there, and we have the sodium here. So the sodium and chlorine, which are the product of electrolysis, are prevented from coming to contact, in which they are going to violently react. As a result, we remember here in the cathode, we also have calcium ions there. So the calcium ions will also move to the cathode. But only sodium is being discharged here. Why? Because the concentration of sodium ions is higher than calcium. So therefore, according to the factors affecting the preferential, rather selective discharge of ions at the cathode, the concentration. Highly concentrated ion will be selectively discharged as compared to ions in lower concentration. So sodium ions are in higher concentration and they are going to be selectively discharged and not sodium. That is point number one. Number two, sodium is lower in the electrochemical area than calcium. Therefore, again, it's going to be preferentially or rather selectively discharged. That's it. But remember, as the concentration of the sodium ions decreases and the sodium ions continue being discharged the cathode, a point will be reached whereby its concentration becomes lower than that of calcium. And at that point, calcium ions can also be discharged here to form the sodium, to form the calcium metal. So how do you separate now the calcium and the sodium? Because there are two ways in which that separation can take place. So finally, you may end up having calcium here and sodium here. So how do you separate calcium and sodium? The properties of calcium that make separation possible will be this one. First of all, calcium is denser. Calcium is denser than sodium. Therefore, it will float, and therefore the one will form the top layer, and therefore it will be easily be able to be channeled out and collected in the condenser here. Number two, calcium has a higher melting point than sodium. Therefore, on cooling, it solidifies fast and now can be easily separated. So those are the points that you need to look at. So the role of the iron wall, that is this one, which is filled with fire bricks, is to maintain the high temperature so that the electrolyte does not solidify. So from that, I've tried to answer all the questions that are very, very important. Remember, the steel is the cathode is made up of steel or iron, because iron will not react with sodium. But the the anode must be made up of what? Of graphite, because the graphite is inert and does not react with chlorine even at that high temperature. And as you can see, the entire chemistry of extraction of sodium is in this particular diagram. So we look at the equation, the cathode, we have already looked at them. That is the cathode, the sodium ions will gain electron to form the sodium metal. Molten sodium is less dense than the electrolyte, and they raise it to the top of the cathode, whereby it is periodically removed. So we are talking about this diagram here. So the sodium is less dense than the electrolyte. So it will float on top and is going to be periodically removed. That's it. The other one is at the anode, chloride ions are discharged to form chlorine gas, which escapes by the hood, as shown in that particular diagram. Remember, I just want to highlight something that is very common with students. When we tell you to write the equation the cathode or the equation the anode during an exam, remember that an equation should be balanced using the simplest mole ratio. In many of the publications, they have tried to balance 2 sodium, 2 electrons to form 2 sodium metals. That if the examiner tells you to write an equation that occurs at the cathode or occurs at the anode, you simply write the equation using the simplest mole ratio. You don't have to balance the electrons, because an equation, a correct equation, should simply be balanced using the simplest mole ratio. Very important for you to be able to capture that. We go to the next. The extraction for the electrolyte is molten sodium chloride. High current of 30,000 amperes is passed through the electrolyte to decompose the ore and to maintain the ore in liquid state due to resistance. So you can be told, normally we use the between 30 to 40,000 amperes is passed through there, and that is the current that is passed through the electrolyte. The role of the high current is to decompose the ore and maintain it in liquid state. The chlorine gas is liberated at the graphite anode, whereby molten sodium is formed at the steel cathode. We have already captured that in the equations. Another point to note is this: the graphite is the most suitable substance to be used at the anode because it is inert and does not react with chlorine gas even at higher temperature. So if you replace that one with something like iron or sodium, iron or steel, then the iron will react with chlorine, forming iron 3 chloride. So, but we use graphite because graphite does not react with chlorine even at high temperature. The role of the hood, it collects chlorine gas and will channel it out where it is tapped to prevent it from being released to the atmosphere, as it is poisonous and hazardous to the environment. So that's why we have the hood that is going to collect chlorine gas and direct it out, whereby it is trapped, or rather it is tapped to prevent it from being released to the atmosphere, whereby it's going to cause a lot of environmental pollution if released. It can even lead to death. So the steel diaphragm is suspended between the cathode and the anode to prevent the sodium and chlorine formed from recombining at this high temperature. So whereby they're going to violently react. So they're going to react violently. So the role of the steel diaphragm is to prevent the products of electrolysis, that is sodium at the cathode and the chlorine at the anode, from coming to contact whereby they're going to react. The steel cathode does not melt as its melting point is higher than that of sodium chloride and sodium metal. Very important to capture that. The calcium can also be discharged at the cathode. The calcium is separated from the molten sodium, not calcium. The calcium is separated from the molten calcium because so this is sodium this separated from the sodium. This is sodium, not calcium. So we are talking about sodium here. So the calcium is separated from the molten sodium because calcium has a higher boiling point. So on cooling, it can be able to correct that. So we are saying that calcium can also be discharged at the cathode. So finally, you may end up having both sodium. You may end up having both sodium and calcium at the cathode. So how do you separate them? So the calcium is separated from molten sodium because calcium has a higher boiling point. So on cooling, it is solidified out fast. Number two, calcium is denser than sodium. So those are the two properties that make the separation of calcium and sodium at the cathode possible in case both of them are formed, that is after some time. So we also look at that the downside is surrounded by iron wall that is filled with fire bricks, forming heat-resistant wall. The purpose of the iron wall lined with fire bricks is to maintain the high temperature so that the electrolyte does not solidify. Very important. The role of the iron wall that is lined with fire bricks is to maintain the high temperature so that the electrolyte does not solidify. So we look at the pollution effect that is associated with the extraction of sodium, and we have formation of gullies. Chlorine gas produces poisonous when inhaled, also causes the noise pollution. Very important. Uses of sodium. Sodium is used in sodium vapor lamps. We also have used in manufacture of sodium peroxide, which is used as a bleaching agent. Sodium cyanide, which is used in extraction of sodium or of gold, not of sodium. So remember, wherever you are giving the uses of sodium, don't give the uses you learned in chemical families. Because that one we are asking you. We are teaching the uses of sodium and its compounds. But this is specifically use of sodium. So used in sodium vapor lamps, in the manufacture of sodium peroxide, which is a bleaching agent, sodium cyanide, which is used in extraction of gold. We also have molten sodium used as a reducing agent in extraction of titanium from its chloride. A mixture of sodium and potassium is used as a coolant in nuclear reactors because it has a low melting point and is a good conductor of heat. Very important. So we are looking at advantages of downcell. The sodium metal obtained has a high degree of purity, about 99.5%. The starting material, that is sodium chloride, is very cheap. Chlorine obtained is a useful byproduct. And this whereby the examiner will ask you which other industry should be located near a sodium extraction plant. And you're going to say the other industry that should be located near a sodium extraction plant is industrial manufacture of hydrochloric acid, because one of the raw materials that is required here is chlorine gas. Then you can have some revision exercise, two properties of sodium that make it possible to be separated from the electrolyte. It is less dense than molten sodium chloride and also has a lower melting point than molten sodium chloride. Those are the two properties that makes the extraction of sodium possible, or rather separation of sodium from sodium chloride possible. The two reasons why sodium is preferably discharged instead of calcium at the cathode. And I say that sodium ions are lower in the electrochemical theory than calcium ions, and sodium ions have a higher concentration in the electrolyte than calcium ions. Then, for such kind of analysis, we are now going to give you the Octopus assignment. From there, you can be able to get the Octopus assignment from here. And from this particular thing, you can be able to get that, you'll be able to get they have come up with the top-notch chemistry guru, which is going to have a simplified analysis using the Octopus technique. So I'm going to show the example of analysis of this particular metal, use the Octopus technique. And if you want to get the answers, more questions for the other metals, you can get yourself a copy of Octopus Revision Guru, which, like the way you are looking at that octopus with all the tentacle there, is going to look at all the possibilities in which the examiner can think. This now the central point, assume this is the metal. So all these tentacles are showing you all the possibilities in which the examiner can imagine. So look at this question. That is a diagram that can be given to study the diagram below. Then you use it to answer the question that follow. Look at the questions. Look at those questions now. So let's get that. Write equation for reaction take place the graphite anode. You are told in this project the anode is surrounded by diaphragm. What is the purpose of the diaphragm? All the way, including calculation, all the questions of sodium that can be tested by the examiner are captured here. You can see from A up to F, about 30 marks from here. We are able to drive 30 marks from here. We are not, I'm not yet done. There are more questions here. You can be able to look at that. Still, we are talking about extraction of sodium. We are still talking about extraction of sodium. You can be able to look at all those questions. Why is the anode made of graphite in this case instead of steel, which is a better conductor of electricity? All the way, all the questions that can be asked, you can be able to get that. So to be able to get those kind of questions, is important to understand that to be able to answer those particular questions, you'll be able to understand how to get these questions for sodium, for aluminum, for zinc, for iron, for lead. Get a copy of the Octopus. And also to get such notes, if you have liked the note that I've used in this particular this question, you can also get a smart note from the top-notch book 4. So I'm going to end with by showing you a video about the top-notch product that we have. So you can be able to get a copy of
Top-notch notebooks and workbooks. Why have a notebook and a separate revision book while top-notch? Edu Creations' unique notebook and workbooks give you both at a price of one. Our products have comprehensive and accurate notes, challenging areas demystified and clarified, summative, objective-based revision questions, and are inclusive of all past KCSE questions. Introducing the Chemistry Octopus Guru, the all-inclusive top-notch revision book for the student who wants the ultimate top grade. For more information and orders, call us on 0728 951 320 or 0711 911 055.